Hi everyone. Today we are going to discuss about rearrangement in carbocations. That is 1, 2 hydride shift, 1, 2 alkyl shift, 1, 2 phenyl shift. Regarding this concept, with different examples, with clarity explanation I will give to you. You just follow it. Then after completion of this video, you can feel it. It is very easy to do different types of questions from this concept. I am giving guarantee. Follow me. Yeah. First of all, I am going to take one example here. 1, 2, 3. This is CH2. Here bromine is bonded. So it is CH3, CH2, CH2Br. Right. This is a 1 bromo propane. Right. It is react with aqueous NaOH, sodium hydroxide solution, caustic soda. Right. It is a positive part Na plus, negative part OH minus. So this is a nucleophile. Yeah. So what is the major product formed? Major product. Generally here students will expect, so this is bromine will go out. It is a living group. It leaves. Then this carbon gets positive charge. Okay. Then this OH minus nucleophile will attack. It will attack this carbon carrying positive charge. Then you will get, this is the product. Yeah. Right. There is CH3, CH2, CH2OH. That is prop plus N plus or propanol. But this is minor product. This is not the major product. It is only 10% is formed. Then what is the major product? That is here this nucleophile OH minus will attack. How it attack is here. This carbon hydrogen bond, adjacent carbon is there, right? This hydrogen bond, carbon hydrogen bond undergoes hydrolysis, unequal breaking. This hydrogen takes up the 2 electrons and migrated over here and it gets stable. Then this carbon gets positive charge. Previously it is primary carbon. Now it is getting secondary carbocation, right? Yeah. Now the nucleophile attacks. The nucleophile attacks. This is secondary carbocation. Yeah. Then you will get, this is the major product is OH is bonded to secondary carbocation. It is CH3, CH, OH and CH3, right? So this is the major product. It is 90% it is formed. 90%. This is the major product. Yeah. How can we explain for this? Now the explanation is here. If this bromine will go out, then the OH minus nucleophile is coming, it is attacking, right, as a reagent, attacking reagent, right. Then after that, what we will get here, if it is go out, if this hydrogen, that is this bromine will go out, you will get this carbon getting a positive charge. So this is a primary carbocation, right? Yeah. Then this is H2 plus, then OH minus will attack. It is attack reagent, it is coming in, Br is going out and OH minus is coming in, it is attacking to the primary carbocation. Then you will get this product. Yeah, but this type of product, it is only 10% is formed. Okay, so because you are getting here a primary carbocation is less stable carbocation. The stability, order of stability of different carbocations is tertiary carbocation is more stable, next to secondary, next to primary, right? Yeah. So that's why here you can convert the formed less stable primary carbocation into more stable either secondary carbocation or it is possible tertiary carbocation, right? For that we have to follow this rearrangement of carbocations. How? There is some of the atoms or groups are shifted from adjacent carbons. Okay, then that makes the less stable carbocation into more stable carbocation. For that, the shifting of the atoms, that may be hydride shift or alkyl shift or phenyl shift, shifting of the atoms from the adjacent carbon, neighboring carbon, brother carbon or sister carbon is take place. That gives more stable carbocation. So this is called shuffling of the atoms, adjustment of the atom, shifting of the atoms. I am not adding anything to this carbocation. I am not deleting from the carbocation anything, just shifting of the atoms is take place. That is called, that will help to convert the less stable carbocation into more stable carbocation. That is called rearrangement, reshuffling, adjustment, the shifting of the atoms. That is called what? Rearrangement of carbocation. Is it clear? Yeah. Then how it happen here? So in this case, how this major product will get? Look here. So for this one, you get it, that is here. So we just represent this one for our convenience to easily understand here. This is this is given here. So this is will go out. You will get this is a CH2 plus. This is a carbocation, and here adjacent carbon is there. So this adjacent carbon is a brother carbon or sister carbon. So once this carbon is crying unstable, immediately this brother carbon says, "Don't cry. I am here. I will do something. I will give stability to you like that." Yeah. Then what happened here? This carbon hydrogen bond is that. Okay. So this 2 electrons are taken by this hydrogen, and it is removed as H minus hydrogen ion. So as a hydrogen ion, okay, so it will go and attack this carbocation. Yeah. Then what you get? You will get a intermediate, there is a transitional state you have to call. So this is this hydrogen will attack here. Okay. Okay. Already here 2 hydrogens are there. Yeah. Now it is going to stable. So 2 bonds and here 3 and 1 4. Okay. But if these this hydrogen as a hydrogen, it will take the 3 electrons and make a bond with this, then this carbon gets positive charge. Yeah. So then you will get here a secondary carbocation. It is bonded to 2 other carbon atoms, right? This carbon is bonded to other carbons, so it is secondary carbocation, right? Yeah. Okay. Yeah. So this is state. How it is formed is here. That is mechanism here. So this hydrogen, it go and attack this one. Okay. Yeah. And it is making a bond with that. So then in this state is called a transitional state. Yeah. Okay. So then after some time this is called transitional state, right? If you get a more stable transition state, then from that more stable intermediate is formed, then the faster the reaction. That means the transition state is stable, then the reaction is faster, right? Yeah. So then this is the transitional state. Then from this, of that what happened? So this bond is completely break up of the bond. Okay, this is breaking of the bond. Then this the 2 electrons are taken by this and make a bond with this completely a permanent bond. So okay, so then we'll get the product is like this. You'll get here CH2 and this is get positive charge. Yeah, this CH3, CH positive charge, CH2, and this hydrogen is make a bond. Then it is become into what? CH3. So 2 hydrogens become into CH3. It is stable now. Yeah. Then this carbon gets positive charge here, right? Now nucleophile will come. Nucleophile, it is OH minus. The nucleophile, it attacks this secondary carbocation, right? Then make a bond with this. Then you will get this is the major product. Yeah, is it clear? Right? Okay. Now here in this case, that means the form is a primary carbocation. This is a less stable carbocation is becoming to now it is a secondary carbocation. Right? That means the less stable primary carbocation, is undergoes rearrangement, that is called shifting. Who shift here? Hydrogen as a H minus by taking electrons. So that is from where to where, from this carbon to other this carbon, there is 1,2 hydride shift. 1,2 hydride shift. So then we will get a more stable, secondary carbocation. So this type of shifting of the hydrogen is from to get less stable carbocation into more stable carbocation is called rearrangement of carbocation. Right? Is it clear? Yeah. That means if the less stable primary carbocation, okay, is unstable, it is crying, right? Okay. Then the charge of the primary carbocation, okay, is taken by adjacent carbon. Okay. Yeah. Okay, the charge of the primary carbon is taken by this one, and it provides the atoms or groups to that carbocation. Then it's going to stable, right? Got it? Okay. So this type of things is called as what? Rearrangement of carbocation. Got it? Okay. That means the positive charge on primary carbocation, okay, is taken by adjacent carbon atoms. Is taken by adjacent, there is a brother carbon or sister carbon, adjacent or neighboring one, okay, brother carbon or sister carbon, right? So adjacent carbon atom, and which in turn gives atoms or groups to that atom, okay. The positive charge on primary carbocation is taken by adjacent carbon, okay, carbon atom, and which in turn provides, which in turn gives hydrogen ion or alkyl ion or phenyl ion, okay, that is, which gives atoms or group of atoms, it is hydride, okay, or group of atoms or groups, okay. So which in turn gives atoms or groups to that primary carbocation and stabilizes it, okay, to that primary carbocation, okay, and stabilizes it, right, and then it is converted into or becomes into, it is converted into more stable carbocation itself, okay, itself converted into, okay, itself converted into, we can call it as, that is itself converted into more stable carbocation, itself converted into more stable carbocation, right? So this phenomenon you have to call it as carbocation rearrangement. This phenomenon we have to call it as rearrangement of carbocation. Rearrangement of carbocation. Is it clear? Okay. So this is the concept is clear, right? Okay. So whenever the primary carbocation is unstable, it is crying, then the adjacent carbon atom, it gives its atoms or groups to that primary carbocation and itself is converted into a more stable carbocation, right? That means the hydride, that is the atoms or the group of atoms are transferred, shifting is take place, right? So the shifting of the atoms or group of atoms that makes that atom, that carbocation is stable and itself is converted into more stable carbocation. So this stuff, that means the rearrangement, what the main aim is to convert the less stable carbocation into more stable carbocation, to become the more stability to increase, then this rearrangement is take place. Is it clear? Right? Copy it, my students. Now we'll do different examples. Wait fast. Yeah, can I erase it now? Right. Next one. Another example. So now in this case, I am doing now one small change I am doing, the second example. Okay, you can understand it very easily. So here how many carbons are there? 3 carbons. And here I am just making here one more carbon atom. Here, one more carbon atom, that is methyl group. Okay, and this is CH2 plus. That is CH2 or something is there, CH2 cell something. Okay, so then here what is there? Hydrogen atom is there, right? So here 2 hydrogens are there, here hydrogen, but here methyl group. In the place of this, I took methyl group. That's it. Yeah. So there is a change I made here. Now, it is how it is rearranges now. Okay. So in this case, it is a primary carbocation, right? So this is a primary carbocation. It is less stable, right? To become the more stable here, adjacent carbon, brother carbon, sister carbon having hydrogen atom is there and methyl group is also there. Okay. So which will shift here? There is the thing here. So if it is hydrogen is shifted from here to here, okay. So it takes up the 2 electrons and shifted here. Then what you will get? we will get here carbon, carbon, here carbon, and it is getting that is the 3 hydrogens will get now. 2 become to 3 is stable, then this carbon gets positive charge, right? Or otherwise, if methyl group is shifted now, if shifting of methyl groups, it takes up the 2 electrons and make a bond with this, shifting of the methyl group, okay, then what you get? You will get now, this is a carbon, carbon, and this become into CH3, and here this hydrogen atom is there, and this is get positive charge, right? Okay. So here 1, 2 hydride shift is take place. Okay. Yeah. Then in this case 1, 2 methyl group is shifted here, right? 1, 2 methyl group is shifted here, right? Okay. Then which is correct? Yeah. Come here. In this case, after that, after shifting of hydrogen ion, so this formed carbocation, it is bonded this side with 1, this side with 1, this side with 1, 3 carbon atoms. It is bonded 3 more carbons, then it is a tertiary carbocation. A tertiary carbocation, right? But here in this case, the carbon carrying positive, this carbocation is bonded this side with 1, this side with 1, okay? And what is shifted here? This shifted is, which one is shifted here? This, yeah, methyl group is shifted, right? This methyl group is shifted, right? There is this CH3 group, methyl group is shifted, right? There is CH3, methyl group is shifted, okay. So this one, methyl group is shifted here, right? Got it? Yeah. Then you will get, this is bonded, this secondary carbocation, you will get, secondary carbocations get this carbon, this is secondary carbocation, okay, yeah. And here this is a tertiary carbocation, yeah. So which is more stable? Here the primary carbocation is converted into tertiary carbocation by the shifting of hydrogen. Here the primary carbocation becomes into secondary carbocation by the shifting of methyl group. Then which shift is take place? Tell me now. So this hydride shift, because it will getting more stable carbocation. Okay, then secondary, tertiary is more stable, right? So that's why it is from more stable carbocation. That's why this shifting is take place. That is 1, 2 hydride shift is take place, and 1, 2, that is 1, 2 hydride shift is takes place. Okay, but this is somewhat less stable than this one. So that's why 1, 2 methyl shift will not take place. So okay, so which is take place, my dear students? 1, 2 methyl shift is this is getting more stable. So that's why 1, 2 methyl shift is take place. Is it clear? Okay, okay, got it, my dear students? Okay, that is got it, my everyone? Yeah. So then then now, so the nucleophile will attack this one, that is OH minus, will get the more stable product. Okay, fine. Yeah. Next one. One more compound. One more example now. The next case, one small change I am doing, my dear students. Okay, one small change. Don't need to buy hard here. Organic chemistry is very logical. Logical preparation is very important. Then it is very easy to do without confusion. Yeah. So now here this is a CH2 plus. Okay, and here methyl group is there. I am taking that methyl group as it is. In the place of this hydrogen, now I am taking out methyl group. Yeah. So here all sides what are there? Methyl groups are there, and it is crying. It is unstable. Then which shift is possibility? There is no any other chance. Here hydrogen shifting is not happening because hydrogen atom is not there. Yeah, that's why only that is methyl shifting take place, right? So they will ask, so in this compound which shift is happening? That is methyl shift, 1, 2 methyl shift. So this 2 electron taken by this, anyone, all are same one, right? So this 2 electron taken by this one, and as I said, minus it is bonded this. Then you will get, that is 1, 2 methyl shift is take place. 1, 2 methyl shift is take place. So because of 1, 2 methyl shift, 1, 2 methyl shift, so what you will get? You will get at first we will explain that it's a transition state is formed here. Okay, so this methyl group, it is going and make a bond with this. Okay, got it? Yeah. So this is the transitional state. This is the transitional state. Yeah. Okay. Then So this one, this is yeah, transitional state. Then we'll get it is a transitional state. After some time, what happened? So this bond is completely break up and this bond is completely make up. Yeah. So this get a permanent bond. Then you will get that is 1, 2, 3. Your methyl group is there, and this one, this methyl group is shifted from here to here. I just represent here. Now this carbon carrying positive charge. Yeah. This carbon, so this is it is bonded to 3 other carbons, methyl groups, alkyl groups. So that's why it is a tertiary carbocation, right? You know, tertiary carbocation is more stable carbocation. Yeah, that means here this one, the primary carbocation, okay, is converted into, becomes into more stable tertiary carbocation. Is it clear? Okay. So here 1,2 methyl shift is take place. Got it? Is it clear? Next one more example. One small change I am doing, you have to prepare logically. See, look here. So this complete concept you can understand by using one example only. The remaining everything is just small changes you have to do it. Yeah. So look here now. This is the concept I am giving ready-made to use it. Okay. So here what is there? Here methyl group is there. Okay. Yeah. And here I am taking now ethyl group. I am taking now CH2, CH3. Yeah. So this is ethyl group. Et means ethyl group, and this is methyl group. This is also methyl group. These two are methyl groups. Right. This is methyl. This is also methyl group. Yeah. Okay. Yeah, it means methyl group. Okay. It is means ethyl group. The CH3, CH2 ethyl group is there. Then methyl shifting is happening or ethyl shifting is happening. How can you decide? That is, look here. So in this case, see, for example, if they say this group, that is this shift, it is happening, then what will get these 2 electrons taken by this one and make a bond with this? Yeah. So then 1, 2, ethyl shift is take place. Okay. Then what you will get? What you will get? Yeah. So what you will get? You will get now here. This is carbon, yeah, and this is methyl group is there, okay, and this is CH2 plus, okay, yeah. Then this ethyl group is make a bond with this, okay. That is CH2, CH3, okay, yeah. Then it is a transitional state, yes, it is a transitional state. Now here this carbon, this is carrying that is okay. So this is it is not, it is a partial bond, right? So still it is not complete. It is not, no, that is not final product, right? That means it is carrying positive charge, right here. Okay, it is a partial bonds are there, not permanent bonds. So that's why once it is unstable, it is correct. It is okay. So then what about who is there here? Methyl group is there. So methyl group is electron releasing group or positive and negative effect group. Okay. So that's why it releases electron to this CH2. Then it is going to more stable. Then it is readily give electron to that. Got it? So this CH2, it is this whole thing, and this is belong to this one. Yeah. Got it? Yeah. Now, so what you will get now, it is completely make up a bond. Then you have to represent now. So you have to remove this. Then what you will get, you make it completely bond. Then you get 1, 2, 3. Here CH3, and this one. This is CH2, and then this ethyl group is there, right? This ethyl group, this group, okay, this is the ethyl group. It is making bond with this, it is making bond with this. We will get now, it is CH2, CH3, so this is a ethyl group, right? Then this carbon gets positive charge. It is a tertiary carbocation. It is a tertiary carbocation, right? That means if ethyl group is shifted, then more stable transition state is formed than methyl group. Why? Because here this CH2, CH3, this methyl group is there. So that's why it is releasing group. It will give more stability to the transition state. If the transition state is more stable, the formed transition state is more stable, then that gives more stable intermediate. Then from that, the faster the reaction. Okay. That is the more stable transition state, faster the reaction. Right. So that's why instead of methyl shifting, ethyl shift is take place. Okay, this is called what? Ethyl shift. Okay, that is from this you get a stable transitional state. So that's why that makes the reaction faster. So faster the reaction takes place. Faster the reaction takes place. So that's why instead of methyl shifting. Ethyl shifting gives a more stable transition state. From that you get the more stable product